once you get introduced to thermal energy, you're going to be running into conductors and insulators. So when you transfer energy between two substances, so you may recall that basically that transfer is kind of typically referred to as heat, and I can point you out in that direction, and I think that you should kind of be familiar with heat and then the different ways that you can transfer that thermal energy, which is one of them is actually conduction, and then convection and radiation. And as you can see here, that word conductors definitely goes hand in hand with conduction as a transfer of energy. So what are these two things? Well, as we deal with substances in physics and in actually everyday life, we may want to be able to know which particular substances or objects are going to be able to transfer the thermal energy easier than some other ones, which do not really act, as a very good transfer or a medium of transfer of that thermal energy, and those are insulators. So typically what happens, as you can see here right on there, it says that metals allow for an easier transfer of thermal energy, and these are typically called thermal conductors. Now we do put kind of right in front the word thermal because we are referring to the thermal energy, but very often that may be dropped. Now you may also see that there's conductors and insulators with regards to electrical energy and that transfer. But here I'm just referring to thermal energy in general. So these particular thermal conductors, we definitely do utilize. So for example, you can take a look and see that anytime you're using pots or pans kind of in cooking, well, they will be made up of some kind of a metal. And the reason for that is because when we do put these on actual an oven, so through conduction, it's much easier for us to transfer the energy from the oven itself to the actual pot or pan, and then that pot or pan is going to be able to help us to get our cooking done, so to try to change the energies of whatever it is, of water, or vegetables, or whatever that we're dealing with. So these thermal conductors, the main thing that you should be aware of is the actual ease of transfer. So that's kind of the main idea behind these thermal conductors, that they allow for an easy transfer of thermal energy. It's much easier to be able to do that. Now, on the other hand, it's kind of non-metals, typically non-metals, but this doesn't mean that they have to be non-metals. They can be any kind of substances that we're dealing with. If they do not allow for an easy transfer of this thermal energy, so in one of them, for example, is plastic, but you may also see this with wood, so you see a wooden spoon, that you typically will steer things around with. And the reason for that is because it is a very good thermal insulator, which just simply means that it doesn't allow an easy transfer of thermal energy. It's much more difficult to be able to do that. So, and that has something to do with the actual properties of the materials, which we don't necessarily may want to get into here from the viewpoint of physics, so that's kind of, we'll leave that towards the chemistry side. But you can certainly think that it has something to do with the actual bonding, and then the ability to be able to create those kind of vibrations, that kinetic energy that the thermal energy is made up of. So in those plastics, so for example, as we use, so if you might have a pot or a pan, you may notice very often that the handles are typically plastic or some kind of an other insulator, and you do not feel the heat. But if you try to touch the actual pot itself on the metal, you're most likely going to get burned because of the fact that it's going to be extremely warm, or in fact super, super hot. Now, some other aspects with regards to thermal insulators, which you should be aware of, is typically things to do with air, or some kind of gases. So air in general is typically a very good insulator. And, we hope that indeed that it is, because of the fact that, if we do have things that are heating up, well, we don't want the air around it, to be kind of increasing, in its thermal energy too quickly, right? Because it would obviously hurt us. And one of the reasons why air is such a good insulator, and that's a very good question to ask, sometimes you might see it on quizzes or tests. Why is air a good insulator? Well, you can think about gases, and please remember that within gases, those potential energies, those bonds are kind of broken, right? So they really just typically have just kinetic energy. And also they're very spaced apart. Now, what is spaced apart, it's the particles that are making up air. So we may not necessarily see them, but they're still there. And because of the fact that there is, such a big, enormous space between them in comparison to, for example, like a metal, okay, or many of the solids that we deal with, well, that allows, okay, for a good insulation. So it doesn't allow for a very good transfer, okay, of the actual energies, okay, that thermal energies to go through. And that's one of the reasons, okay, for example, within many of the animals, so from having fur, or hairs or feathers, those do actually act as insulators. And the main reason is because they trap the air. So they trap the air between the actual fur or between the feathers, and they do that very well. And then that acts as an incredible insulator. So it keeps the animals warmer when they need to be, okay, and sometimes cooler if it's extremely hot, right? So when they're exposed to the environment. So those actual feathers, okay, and furs are trapping the air inside, and air is a very good insulator in general. Now, one of the best insulators that we have, or that we hope for, okay, to be able to set is, well, if air is a very good insulator, what if we would remove all of the particles, right? So if we would remove all of the particles from the air, well, then obviously we would have no oxygen or anything else, so we wouldn't be able to live. However, we can use this kind of removal of all the particles from air, basically making it an empty kind of substance, so there's really nothing there, and we call that a vacuum. So if you have a vacuum, which you have maybe heard of, okay, and this is not the cleaning vacuum, but it's the vacuum where we have just kind of sucked out all the particles. And those particular it's not really no longer a substance, there's just nothing there. They are obviously very good insulators. And why? Well, because of the fact that you can no longer have conduction taking place, okay, or convection. And that's really, really good, okay, for us, right? Because of the fact that if you do have now two substances or objects, okay, in contact in some way, then, okay, if there is nothing in between them, so if you separate it by a vacuum, well, then what you're creating is you can't really transfer that energy over. And we do use that very often. So if you think of a thermos, for example, so, if you were drawing out a thermos, so here I'm going to try to kind of illustrate. So here's my thermos, okay, and what happens is that this inside, so it's almost like a vacuum that we create, we suck out all of the particles. Well, we try to do that as best as we possibly can, right? And then this, will get sealed, okay, kind of like this. And then you have your cap over here, and all of this inside, right, which is the least amount, okay, of air particles as possible. So ideally, we would want this to be, in a vacuum, so that anything within here, so these particles, okay, that might be moving around, okay, over here, if they do hit, okay, this particular structure, okay, of our bottle or a thermos, well, then it's not going to be able to do anything, okay, on the inside, because it can't pass on that thermal energy through to impact whatever it is that we have. So if it's our coffee or tea or soup or whatever, and then we can keep it relatively warm. Now, some of it still escapes because we have a cap, and obviously we sometimes open it to drink it, whatever we have inside, but this particular cap obviously is not going to play an enormous role, and it does slow down the process of thermal energy transfer, or that heat transfer that we would have, because you do have a vacuum and nothing's inside, and you can't stimulate any particles, okay, at all, right? So that's what we have within there. Now, these particular vacuums are used, okay, all over, and it's not just with regards to keeping things warm, it's also, keeping them cool. If you're using it for, cold water storage, it certainly will work for you much better than just a regular bottle. And that means that, it's not going to increase the temperature of that particular item, okay, or substance from water, coffee, or anything that's inside because of that vacuum. All right. So these are kind of a couple of items that you should be aware of as you're heading into, talking about thermal energy in general and studying physics. You should know what conductors are and then what insulators are. And don't forget, conductor, the word, is kind of a reminder of conduction, right? So in that particular process that you have. And insulators, well, they kind of do the opposite. They try to slow down the process as much as possible. All right, so thanks for watching. We'll see you in a future video. Bye, everybody.